After the Trump era in the US, the Biden administration rejoined the Paris Agreement and declared an ambitious plan of 50% reduction in greenhouse gas emissions by 2030 relative to 2005 levels. Therefore, imposing some form of carbon penalty, for example, carbon price, carbon fee, or carbon tax, will be a crucial component for addressing carbon emissions in the USA. A carbon penalty would incentivize producers and consumers to shift expenditures away from carbon-intensive products and services, e.g. coal or natural gas-generated electricity, and toward low-carbon alternatives. However, if not implemented in a way that takes differences in household income into account, this policy strategy could place an unequal burden on low- and middle-income Americans. So, what's the best way to ensure an energy transition that does not widen the gap between rich and poor households? As already implemented in Canada, revenues from carbon penalties can be used to compensate all households in the form of a carbon dividend. For example, a $50 per metric ton CO2 tax would return each U.S. household an annual dividend of around $1,500, more than the pandemic stimulus checks distributed to most U.S. taxpayers. However, this proposed policy runs the risk of reducing the overall efficiency of the U.S. economy, which would lower the nation's GDP and impede its economic growth. Other revenue-neutral designs, such as reducing taxes on labor, could improve the U.S. economy, but it would be less favorable than a carbon dividend to lower-income households. So, it seems that there are clear trade-offs between efficiency and equity of different uses of carbon revenues. But is there a sweet spot to avoid harm on lower-income Americans and degrading economic efficiency? Searching for the answer, researchers at MIT and BC3 have assessed the social-economic impacts of different uses of carbon revenues. Their results show the following. The researchers find that carbon dividends have progressive impacts on households, with the greatest benefits going to the lowest-income ones, while policies centered on improving the efficiency of the economy, e.g. payroll tax reductions, have slightly regressive impacts. But what would happen if we combined both policies? With only part of the carbon tax revenue used to compensate low-income households and the rest used to improve the economy by reducing payroll taxes. This option will result in an optimal blend of sufficiently progressive impact at the household level and economy efficiency at the national level. Therefore, we can eliminate the potential trade-offs between efficiency and equity, and promote a just and efficient energy transition. To sum up, our study demonstrates that it is possible to introduce ambitious climate policies in the U.S. while ensuring a just energy transition that does not jeopardize economic growth. Our best chance of achieving a low-carbon economy goes hand in hand with designing policies that are effective in promoting a better distribution of impacts.